Hello, everyone. So for our workshop 3, we were tasked with creating a Turing machine that would accept an input of a string of zeros, ones, and twos, and sort the input in ascending order, and then conclude when the string is sorted. So for this workshop, I used JFlap to build my machine. First of all, I'll just explain overall how it works, and then I'll go ahead and actually share my machine. I know there's a way to make this machine by deleting numbers, but I wanted to make a machine that does not need to use that technique, but rather can sort them without having to delete any numbers. So the way my machine works is it looks for ones first, and it looks for a 1 first, and then it changes that 1 to 0, and then it continues moving right until it finds the next 0, and then it'll change that 0 into a 1, and then it'll move left and repeat that process until the ones are sorted to the right of the zeros. And using this process, we can maintain the same amount of ones and zeros. And then once the ones and zeros are sorted, then it starts moving from left, or starts moving left to look for ones and then turn them into twos. And then it keeps moving left, finds the next 2 and turns that into a 1. And it repeats this process until the whole string is sorted. So with that overview being said, let me go ahead and actually share my machine right here. Let me just find the screen sharing. Okay, so it should be sharing now. This is the machine that I built to solve this problem. And let me go ahead and step through a few inputs to show you how it works. So first of all, let's just start with the string. We'll start with this string. Okay, so first we start in initial state, and it's looking for a 1 here, a 0 here, or a 2 here. And we see there's a 1 right off the bat, so it reads a 1. And then after reading a 1, it moves into this space. And then it also reads the 1, puts down a 0, and it moves on to the next. And then it's next we see there's a 1 in the string. So when it reads a 1, it just loops over that 1. And then keeps looping over the 1s and 2s all the way until it hits a 0 right here. And as we see, it hit the 0 and it put down a 1. And we can see right here, it changed that 1 into a 0, or that 0 into a 1. And then it loops back all the way to the left until it finds that blank space. And then we're back at the beginning. And it moves right and reads the next input. So that next, it will read a 0, as we see here in red. And upon reading a 0, it'll keep that 0 down, move to this state. So we can see that there. And then next, we have a 1. It'll read this 1. It'll put down a 0. And then move to the right. And then next, it will read a 2. And then it'll keep on looping over 2s and 1s. And then it'll hit this blank space. So by the time it reaches this blank space, the 0s and the 1s should already be sorted, or else it would keep looping through here. So next, what we have to do is sort the 2s and 1s. Because as we see here, the 2s are to the left of the 1s, and we want to get those sorted on the other side. So it would be in ascending order. So here, Yes, we hit the blank space, and then we're looping back to the left over the 2s and 1s, back until we hit a 0. And then at this point, we had an extra 0 in our string right here, because if we recall, the beginning string was 112201. So there's only supposed to be 1 0, and there was another 0. So we had to change that 0 back into 1. So now it's correct. And then after that, we keep looping over moving to the right over the 1s, the 0s, and the 2s until we hit our blank space. Then at this point, we move to the left. And we're looking for a 1 to change into a 2. And we have found our 1 right here. So we change that into a 2. And then next it's looking to find a 1. Or no, it's looking to find the next 2. Or if there are no 2s, it would find a blank space. But in this case, there is a 2. So it finds that 2. It puts down a 1. And then it moves to the right. And loops over moves to the right past the 1s, the 2s, and the 0s until it reaches that blank space again. And then at this point, we're looking to find a 2 to keep that 2 there, because at this point, we have changed the 1 at the end to a 2. So there should only be a 2 at the end at this point. So we're looking for a 2. We're keeping that 2 to move back to this state. And at this state, we're looking for another 1 if there are any. And we're looking to change that into a 2, which we see happens right here. And then after that, what we're looking for is a blank space over 2 again. We're looping over the 0s and 1s to the left. We're walking to the left until we find that the next input. So we find a 2, we put down a 1, and then we keep walking past to the right, hit our blank space. Now we're looking for our 2 again, which is right there, keep the 2. And then now we're looking for our 1. And then we change that into a 2. And now we keep going left until we find either another 2 or a blank space. So as we see here, the 2s have already been sorted, so there should not be any more 2s here. So we hit our blank space, and then we're able to transition to our next state. And then once we reach this point, as with earlier, where we had to change that extra 0 back into a 1, we have an extra 2 in our input string, because if we recall, the original input was 112201. So what that means is we should have 2 2s and 3 1s, but we have 3 2s and 2 1s. So we have to change that extra 2 back into a 1, which we do right here. So now, when we reach this point, the string is successfully sorted already, but we still have to make sure, because say if it hadn't been sorted to this point, we would have to go back to the beginning. So we have to check to make sure it's sorting. So we're moving. Oh, we're moving all the way to the left to the beginning of the string. And the first thing we're going to do is we're going to walk to the right past all the 0s. And if our string is sorted correctly, we should find a 1 there. So we found our 1. So that means that the 0s are all in order. There's no 1s or 2s intermixed with the 0s. So we found our 1. We keep that 1 there. We keep moving to the right. Now we want to check our 1s to make sure that all the 1s are sorted correctly and there's no 2s intermingled in there. Because if there was, then we would have to keep sorting the string. But as we see, there is nothing intermixed in here. So the next input should be a 2. Oh, I'm sorry, my bad. So what I was trying to explain is that if the 1s weren't correctly sorted, there might be a 0 intermixed there. So if, say, there was a 0 intermixed in that string still, meaning it wasn't already sorted correctly, it would what it would do, if it found a 0, it would keep the 0 there. And then at this state, it would walk back all the way to the left, all the way to the beginning. And then we'd be back in our initial state. And then we could repeat this process over again. But our string is sorted correctly. So we move past all our ones, keep moving to the right. And then if we move past all our ones, we should expect to see a 2 next. So we do find our 2. And then we keep walking past to the right. And if our 2s are sorted correctly, the next input we are looking for is a blank space, meaning that everything is correctly sorted in order, which it is. And as we will see here, it hits the blank space, and then we reach our accept state, and we have our sorted string right here. So now, let me just walk through another quick example. Don't have a whole lot of time left in this video, so I'll try to be a little bit quicker with this next example. So say we have an input, say we start with a 2 instead of a 1. So let's say 2001. So what this will do right away is upon reading the 2, we have our condition right here where it'll see a 2, it'll put down a 1, and it'll move to the right. So we put down a 1, and then we'll keep walking to the right past the 0s and the 2s until we find the next one to change into a 2. So we find that 1, put a 2 down, and then next we will walk past the 0s, the 1s, the 2s, keep walking left until we reach our blank space. And then we're at the beginning. And then at this point, since we changed that 2 into a 1, the first number here is a 1. So we'll read a 1. We'll change that 1 into a 0 right here. We will keep walking to the right past the 1s and 2s. Well, no, actually the next one is a 0. So it'll pick up the 0 and change that into a 1, as we see right here. And then it'll keep walking past the 1s, 2s, and 0s to the left, all the way to the beginning where we find our blank space. And then next we read a 0 first, keep the 0, keep walking to the right. I'm sorry. It was lagging a little bit, but we found our 1, change that to a 0. We found another 0, change that into a 1. Keep walking to the left till we reach our blank space, move to the right. We found our 0, keep 0. Find our 1, change that to a 0. But as we should note, there is supposed to be a 1, 1, so we will need to change that 0 back into 1, as we'll see in the step right here. Once it finds the blank space to the left, it keeps moving past the 2s and the 1s to the left. And then we see that 0 there. We turn that back into 1. Now we have the correct amount of 1s and 0s. And then at this point, we loop to the right, or we keep walking to the right till we reach our blank space. And then at this point, we walk past the 2s until we find our 1. Change that into a 2. And then we keep walking past left, past the 1s and 0s. And then we find our blank space here. But as we note, we have an extra 2. There's supposed to only be 1, 2, and 1, 1. So right here, we will change that 2 back into a 1 and move to the right. So as we see here, that 2 has been changed back into a 1. So now our string is correct. And we will keep moving to the left until we hit our blank space or the beginning of the string. And then now we're at the point where we're going to check it to make sure that the string is correct. So we're going to make sure our 0s are in order and nothing's intermingled with our 0s. Then we hit a 1 next. We got to make sure that there's no 0s intermingled within our 1s. So we should expect to find a 2 next if our string is correct. We do find our 2. So now we're You're going to loop past, keep walking to the right, past the 2's until we reach the blank space, which we do here. And then now the string is successfully stored and we have our output right here. Okay, so those are the examples I'm going to walk through, but just to show that this does work for any input, real quick, I'm going to do a fast run just to show you that the example given in our workshop, that this Turing machine will successfully sort even a long string such as this. So as we see here, it has been successfully sorted, and they're the same amount of zeros, 1's, and 2's as there were in the original string. So that is my Turing machine I built. I hope it was informative and maybe a little bit of a different way of doing things. And I hope you enjoyed and have a great day. Yeah.